Hello YouTube, we're back at it again. Thank you for clicking on the video today. Make sure to like and subscribe, and let's get on with the video. Sadly, this isn't a Fortnite video. Today we're going to over inference of slopes for AP stats, specifically the Old Faithful activity. Here's some background on the activity, which states that in Chapter 7 you learned about the sampling distribution of a sample proportion p-cap and the sampling distribution of a sample mean x-bar. In this activity, you will explore the sampling distribution of the sample slope b when calculating least square regression lines from random variables. Old Faithful Geyser is one of the most popular attractions in Yellowstone National Park, as you saw in Chapter 3. It is possible to use at least square regression line to predict y equals the interval of time in minutes until the next eruption from x equals duration in minutes of an eruption. In one particular month, Old Faithful erupted 263 times. Your teacher has printed out this population on 263 cards. Each card gives the duration of a particular eruption on one side and the interval of the next eruption on the other side. In our video today, we will not be doing cards. We have a simulation through Statplet. Let's read the instructions. Step 1. Form teams of 2 or 3 students. Step 2. Have one student from each team select a random sample of 15 cards from the population and return to the team. This student should read aloud the duration x and interval y values for each eruption, while the remaining team members enter these values into their calculators or other technology. Replace the 15 cards in the population. After each team has recorded the values for its 15 randomly selected eruptions, the team should calculate the sample least square regression line for its data. Record the value of the sample slope b. It is important to note that for this video, we will be using Statplet, which means we basically get to skip these 3 steps. However, if you're doing this in class, follow your teacher's instructions. Step 4. Your teacher will prepare an axis for a dot plot to display the distribution of the sample slope. Add the value you calculate in Step 3 to this dot plot using the symbol B instead of a dot. Repeat steps 2 to 4 as necessary to get at least 20 sample slopes. Step 5. As a class, describe the simulated sampling distribution. Remember to discuss shape, center, and variability. Step 6. What do you think would happen to the simulated sampling distribution if the sample size was increased from 15 to 50? Discuss as a class. Steps 4 to 6, unlike steps 1 through 3, we will actually go over in this video. This graph on Statplets represents the data of the 20 samples we collected. Here are the results we got from the data. Our least square regression line is y cap equals 12.796x plus 51.5. The 12.796 we got from the sample slope, and the 51.5 we estimated from the intercept shown in the graph on the previous slide. My description of the sampling distribution. The shape of the sampling distribution is roughly symmetric. There appears to be no outliers. We know this because of the 1.5 IQR rule. Our 1.5 IQR for our data is 2.496. If we subtract this from quartile 3, which is 12.291, we get 9.8. And our minimum is 11.117, which means we have no outliers on the lower bound. For the upper bound, however, we also have our quartile 3 is 13.955. If we add 2.496 to this value, we get 16.451. Our maximum is 15.858, so therefore we have no outliers in the whole data. For our center, the median is 13.7715, and although it says median also, it means this is our mean, and our mean is 13.239. Variability, the standard deviation is 1.252 and the range is 4.741. The IQR is 1.664. At last, this activity asks us what would happen if the sample distribution was increased from 15 to 50. My answer is, if the sample size was increased from 15 to 50, the slope of a line becomes higher as the intercept lowers. The line becomes steeper. A higher sample size also decreases the variability, such as standard error, making the data more reliable. That's all for today's video. Thank you for making it to the end. I know I said this wouldn't be a Fortnite video, but I gotta finish what I start. So here's some Fortnite clips, and thank you. Shout out to Martin and Isaiah for helping me in these clips. Mamba out. Oh shit. You got